Hey there, Seahawks. It's Miss Adams, and in this video, we're going to talk about testing a claim for a single mean. All right, so again, the conditions are random, the 10% condition for independence, and the normal condition. So it has to be a random sample. Typically, that will be stated. The independence is where your population value has to be greater than 10 times your sample size. And then the normal condition when you're working with means is typically either going to be stated or you'll use the central limit theorem to assume that a normal model is appropriate, which you can do if your sample size is 30 or more. All right, calculating your test statistic when you're working with means, it's typically t. So again, it's your statistic minus your parameter over your standard deviation of your statistic. Specifically for one mean, it's t equals x bar minus mu over the square root of sx over n. Also, you have one-sided tests, which are ones that are using less than or greater than, and you have two-sided tests, which are ones that are using not equal to. All right, given the test statistic, find the p-value. You are conducting a significance test for a null hypothesis where mu equals 3.5 against an alternative hypothesis where mu does not equal 3.5. After checking the conditions are met from a simple random sample of 28 observations, you obtain a t-value of 2.43. What conclusion can you draw at a 5% significance level? All right, so this not equal to test tells me that I'm working with a two-tailed test, which means I have to look at both tails of my curve. T is 2.43, and they're saying at a 5% significance level. So when I draw this normal curve, because I had a sample size of 28 and I'm working with means, this would be a t distribution with 27 degrees of freedom because it's n minus 1. My t is 2.43, but it's two-tailed, so it's also at negative 2.43. And I want to find that area that would be shaded above and below that test statistic of 2.43. Okay. So in my calculator, I could do second vars. I'm going to do a t-CDF, and I'll put in my lower bound, my upper bound, and my degrees of freedom. I only have to do this for one side because it's going to be the exact same size on both sides because it's symmetric with a normal curve. So t-CDF, my lower bound would be negative infinity, which it may already be in your calculator as negative 1e to the 99, or you can just put in negative 99999. The upper bound is negative 2.43, and the degrees of freedom is 27. And when you put that in, you get 0.011. So that is this section here. I know it's going to be the exact same on the other section. And so the p-value is the area of the shaded region. So my p-value is equal to 0.022. And at a 5% significance level, 0.022 is less than 0.05. So we reject the null hypothesis and have evidence to support the alternative hypothesis. All right, finding the p-value and interpreting. Bottles of Coke Zero are assumed to contain 500 milliliters of soda. There are some variation from bottle to bottle because a filling machine is not perfectly precise. Usually, the distribution of the contents is approximately normal. An inspector measures the contents of 9 randomly selected bottles from one day of production. The results are 501.9, 499.4, 498.7, 501.3, 501.7, 500.6, 500.9, 500.4, and 501.5 milliliters. Do the data provide convincing evidence at an alpha value of 0.05 that the mean amount of soda in all the bottles filled that day differs from the target value of 500 milliliters? So in our calculator, the first thing we're going to do is enter this data into list 1. So we'll hit stat edit and put our data in. Then we'll go to stat test t-test, and then we'll use the data setting instead of the stat setting. All right, so here's all of our data. Our alpha value is 0.05. This is a differ, so it's going to be a not equal to test. And again, our target value was 500 milliliters. So when we're setting up our null hypothesis, it would be mu equals 500. The alternative would be mu does not equal, because it said differs, 500. And if we put this into our calculator and we run the test, we'll get a p-value of 0.083. All right, well, 0.083 is greater than 0.05, so we fail to reject the null hypothesis because our p-value is greater than our alpha value. Therefore, we do not have convincing evidence that the mean target value differs from 500 milliliters. All right, so if we want to run this in our calculator, so we're going to start by going to Stat, Edit, and then entering our list of data, which I already have entered. Then I'm going to go to Stat, I'm going to go over to Test, and I am doing a t-test, which is option 2 here. I am using data, so I'm going to go over to Data, select that. My data is in list 1. I'm going to set my null hypothesis here to 500. My data is in list 1. Frequency we're going to keep at 1. I'm going to change the type of test to a not equal to, and then hit calculate. And we get a p-value of 0.0828, 0.083. All right, go Seahawks.